An open top rectangular box with square base has a volume of 3 cubic feet and it must be constructed. So the material for the base is 6 cents per square foot and the material for the sides is 8 cents per square foot. And then what's the minimum cost to construct this box? So if we think about a square base, it's going to have the same side measurements. So let's just give it a variable x. So it's going to be x as well, x all the way around. And the height of this, we don't know. It's not specified. But this should be y height. Let's just give it a different variable name. Could be the same distance, but we don't know. So it's going to be all y. And we want to find the material cost for this thing. So the material cost for the base. The base, of course, is just this bottom portion here. The base is x times x, so x squared. And it's 6 cents per square foot. Well, this is how many square feet there are. It's going to be 0.06 times x squared. That's the cost for the base face of this box. And the side faces, this is 8 cents per square foot. It is x times y square feet. And this one on this side is also x times y. And the back is x times y. That one's x times y. So there's going to be 4 of them times 0.08 per square foot. And there are x times y square feet. This is our cost function, and it's a function of both x and y. Now, because of that, we actually want to try and find a way of getting rid of one of the variables, and we can using the fact that the volume is 3 cubic feet. So the volume of this box, the volume is 3 cubic feet, and the volume of this box is the length times width times height, x times y. So x squared times y. Well, that means that y equals 3 over x squared. So I can plug this into our function here, 3 over x squared. And now I have a function of only one variable, x. Okay, I can simplify this down a little bit. I can get rid of this x here, get rid of that 2, and this thing, the whole thing becomes, let's see, 3 times 8 is 24, so 0.24 times 4 is going to be 0.96. Just 4 off from 100. And to find a minimum, we need to find the derivative of this thing and set it equal to 0. So the derivative of this would be 0. Bring that to 2, so 0.112 or 0.12 x. And this is the same thing as x to the negative 1. So bring that down and then subtract 1 from the power, so minus 2. That's our derivative, and this equals 0. I'm going to add this over the other side and go from there. So 0.12 x equals 0.96. I'll write it like this, over x squared. Multiply the x squared over, divide by the 12. We're going to get x cubed equals 96. This is going to end up being 96 over 12, which is 8. And take the cube root of both sides. We're going to get 2. So the base length should be 2. And of course, if you do 2 squared is 4. Divide that over, this is going to end up being 3/4. That's not necessary. All we really care about is the minimum cost. So we really just need to plug x into our cost function here. So doing that, we're going to get 0.06. 2 squared is 4 plus, that's going to be 0.24. That's 0.96 divided by 2, which is going to be 0.48, and that gives us 0.72b.